Today we're talking about sequences. What a sequence of numbers is a series of numbers, an ordered list of numbers that follows a specific pattern. We're going to take notes and write this stuff down. What we probably should cross off is this part just to simplify our notes. A sequence is an ordered list of numbers that follows a specific pattern. Here's a sequence. When you're looking at a sequence of numbers, it's important to notice what's going on. In this case, it's getting bigger. Is it getting bigger quickly or slowly?
Quickly.
Slowly.
Kind of slowly, so let's figure it out. I would always check to see what it's increasing by. From here to here, it looks like it's increasing by 4. From here to here, it's once again adding 4. So it looks like each time it's adding 4. If you add the same number each time, that would be the pattern. The pattern in this case would be add 4 each time. We'll talk about it in just a second. That's called an arithmetic sequence. And if you want to get into all the fine details, this number would be called our common difference. We'll talk more about that in just a little bit. Here's another sequence of numbers. 1, 3, 9, 27, 81, and it continues going on. Is this getting bigger or smaller?
Bigger.
Quickly or slowly?
Quickly.
Quickly. So if it's getting bigger quicker, it's going to be hard for it to be addition, because addition is pretty constant. Same numbers, same numbers. So let's see. From 1 to 3, that's add 2. From 3 to 9, that's add 6. We immediately know it's not going to be adding the same number each time, so let's consider a different plan. Anyone have any other thoughts on what this could be instead of adding the same number, which it wasn't? What could this be? Multiply by 3? That's 3, 2? Let's see. Let's try 3 first. 1 times 3? 3. 3 times 3?
9.
9. 9 times 3?
27.
It looks like it's times 3 each time. It's times 3 each time, multiply by 3 each time, and it's called a geometric sequence, which we'll get into in more detail later. And these numbers, where it's multiplying by the same number, those numbers, in this case 3, is called the common ratio. It's called the common ratio. We already mentioned it, we alluded to it, but I'll specifically say an arithmetic sequence goes by adding the same number. So if you want to take notes, it's arithmetic, add the same number. And the key is, again, it needs to be the same number. If it's not the same number, it cannot be arithmetic. If you add 1, then add 2, then add 5, then add 1, it's not arithmetic. Even if you add 1, then add 2, then add 3, then add 4, and there's a pattern, it's not arithmetic. If you add 1, then add 2, then add 1, then add 2, then add 1, then add 2, it's not arithmetic. Arithmetic is adding the same number every single time. Here's an example of an arithmetic sequence. This arithmetic sequence, from here to here, goes up by 6. From here to here goes up by 6. From here to here goes up by 6. Does everyone agree that this sequence is going up by 6 each time?
Yes.
So if I were doing this problem, this is what you might see on your upcoming summatives, it would be add 6 each time. It would therefore be an arithmetic sequence. You would need to mention that, an arithmetic sequence. You would need to mention that the what's called common difference is 6, and you might be asked to find the next 3 numbers, which in this case would be 32, and 38, and 44. Again, on your summative, you would be asked to tell me the specific pattern, add 6 each time, tell me that's arithmetic, tell me what the common difference is, and then find the next 3 numbers. That's what you would be expected to do on all of them. Am I going to do all 4 of those things every single time? Not for here, but just so you know what the expectation would be. This next pattern, 1, 15, 29, 43. What's the pattern in this one? I'll give you a hint, it's going to be arithmetic because it falls into the arithmetic category. But what is the specific pattern for this one? What's the pattern for this one?
Adding 14.
Add 14 each time. And from here to here, you can always subtract 15 minus 1, that's 14. 29 minus 15, that's 14. It looks like someone is adding 14 each time. I would also say again, it is arithmetic. I would say the common difference is 14. Now I find the next three numbers by adding 14. All right, here's a tricky one. What is going on with this one? What is going on with this sequence of numbers? Correct, subtracting 3. What's the problem though with me saying we're subtracting 3 each time? What's the problem with saying subtracting 3? You're absolutely accurate, 100% correct. You are definitely subtracting 3. What's the problem with saying subtracting 3 each time? You don't subtract if it's arithmetic, correct. Arithmetic is always adding. So instead of saying subtract 3, what could I say instead? Instead of saying subtract 3, what could I say instead?
Maybe add negative 3.
Add negative 3, keep change would be the exact same thing. So that's what I would say. Instead of saying subtract 3 each time, in order for it to be arithmetic, I would say add negative 3 each time. So the fact that it's adding allows it to be arithmetic, because arithmetic is always adding. Again, I'm saying arithmetic. I'd say the common difference is negative 3 out by the next three numbers in the sequence. Geometric sequence is the next type of sequence. Geometric sequence, pretty much the same thing. Geometric sequence goes up by multiplying by the same number. And again, it has to be the exact same number. If it is not the same number, it's not geometric. Here's the first pattern. I'll give you the answers right here. From 3 to 6, you might say, well, let me check addition first. Well, this is plus 3. This was now plus 6. So it's definitely not addition. You can check addition very quickly. But let's check the next thing. So from 3 to 6 is also times 2. That's times 2. 12 times 2 is 24. So it's multiplied by 2 each time. We say multiply by 2 each time. We'd say that's geometric. And this time, we would say not my common difference. We'd say my common correct ratio is 2. We would still find the next three numbers in the sequence by multiplying by 2, but that would be the expectation. Is the common ratio for geometric is 2. This next one, pretty much the same thing. If you add 6 and then 24, so it's not adding. If you check your multiplication though, what's happening is this is being multiplied by the same number. It's being multiplied by 4 each time. You say multiply by 4 each time, it's geometric. The common ratio in this case is 4. So it's being multiplied by 4 each time. Here's one that we definitely want to talk about. This one got smaller. Is it possible for a geometric sequence to get smaller?
Yes.
Yes. You might say, well, the way for it to get smaller, just like with addition, is to multiply by a negative. So let me multiply by a negative. When you multiply by a negative, it just makes things negative. So multiplying by a negative actually won't do that. The only way to go from 20 to 10, you might have noticed, is, well, I could divide by 2. And that's the hint we need. We need to multiply, though, to be geometric. So instead of dividing by 2, what we could say is multiply by 1/2. Because if you look at 1/2, you see this line? It's divide by 2. So multiplying by 1/2 and dividing by 2 are the same thing. Which one's better? For this, geometric would be multiplied by 1/2. Multiply that by 1/2. Multiply that by 1/2. Multiply that by 1/2. If you don't believe me, like watch. 10 times 1/2. Well, the first step for working with fractions is to make them both the fractions. And I multiply. 10 times 1 is 10. 1 times 2 is 2. And of course, 10 divided by 2 is 5. That's how I got to from 10 to 5. So in this case, we would say it is multiply by 1/2 each time. We'd say it's geometric, and we'd say the common ratio is 1/2. The common ratio is 1/2. And you can still find the next couple numbers. Here's one. Can anyone tell me what's going on in this pattern of numbers? The sequence of numbers. What's going on? It's definitely getting smaller or less values. What is going on? Subtracting 5. What's the problem with saying subtracting 5?
You can't subtract.
We can't subtract if we want to call it arithmetic. So what should we call it?
Negative 5. Adding negative 5.
Add negative 5. By saying add negative 5, that means it's also arithmetic. My common difference is -5. And I want to find the next couple numbers be -20, -25, and -30. Let's do this one. From 4 to 12, 12 to 36, that's getting big quickly.
Multiplying by, you're multiplying by 3.
3 times 3, that means it is geometric, and the common ratio is 3. Check out this one though. Got 2 more to do. This one's getting smaller. Definitely not subtracting, because this would be subtract 32 and this would be subtract 16. Definitely not subtracting. Multiply by 1/2 is essentially dividing by 2. So you multiply by 1/2, it is geometric, and the common ratio is 1/2. And the last one I want to show you, because it's trickier, is it getting bigger, smaller, or is it getting bigger quickly or slowly?
Slowly.
Slowly. So let's check addition real quick. From 3 to 5, plus 2. From 5 to 8,
Plus 3.
plus 3. 8 to 12,
Plus 4.
This looks like it might be arithmetic because there's a pattern with adding, but in fact, it's not. This is an example of neither. Because in order to be arithmetic, it needs to be adding the same thing each time. This is a neither. We would say, if I had to describe this, is add 1 more each time. Not add 1 each time, add 1 more. Add 2, add 1 more, add 3, add 1 more, add 4, add 5, add 1 more each time. It's neither, and there's no common ratio or common difference because it's neither.